Today we're going to talk about changing repeating decimals to fractions. There's two different procedures that you're going to use, and we're going to start if you're repeating the same digit. If you're repeating the same digit, it actually means that there are just 9s in the denominator. For example, if you were trying to convert the decimal 0.4 repeating, the only digit you're repeating is the 4. There's no other numbers in front of it, so the decimal is simply 4/9. If you were to check that with your calculator, you can see that 4 divided by 9 is 0.4 repeating. If you have more than one digit repeating, for example, 0.16 repeating, if both the 1 and the 6 are repeating, it's over 99. Since there's two repeating digits, you put it over 2 9s. If you were to check, 16 divided by 99 is 0.16 repeating. And if you were to have 3 repeating digits, for example, 0.417, if you were to repeat all 3 of those numbers, you would put it over 999. So you'd put it over 3 9s because there are 3 digits repeating. So if you were to check with a calculator, 417 over 999 is 0.417 repeating. Now it becomes trickier when you talk about repeating decimals with only one digit and they've got something else in the problem. For example, 0.83, where only the 3 is repeating. Now you have to use a different method. It's an equation, 100x minus 10x. That always stays on the left-hand side of your equation. On the right-hand side of the equation, we're actually going to find out what 100x is and what 10x is, and we are going to solve. So, if you took this number right here, 0.83 repeating, and you multiplied it by 100, it would be just like moving the decimal 2 places to the right. Okay, so if I have 0.83 repeating, and I move my decimal 2 places to the right, my decimal will now be here. Now, even though we write this notation only writing the 3 one time and put a repeating bar over it, if you were to move it to the right, it really turns into 83.3 repeating, and that 3 would continue on, and we would keep on going. If we want to multiply this 10 times x, when you multiply something by 10, it's just moving the decimal 1 place, so this becomes 8.3 repeating, where the 3 goes on forever. Now what we are going to do is we are going to subtract these two numbers right here. So again, you're doing this somewhere to the side of your paper. 83.3 minus 83.3, not 83.8. Okay, the 0.3s actually go away, even if they had repeating bars. If you were repeating the 3 in the top and repeating the 3 in the bottom, they both cancel out. So that just becomes a 0.0. When you subtract 83 minus 8, you get 75. When we rewrite this, we're going to leave off the 0.0. We can just leave it as 75. So if I took 100 times my value and then 10 times my value and subtract them, I get 75. Now you're just solving this equation. On the left side, 100x minus 10x is 90x. It's always a good idea to draw a line through your equal sign to help you separate the two sides of your equation. Bring down the 75 because you haven't touched it yet. Divide both sides by 90. The 90 goes away on the left-hand side because that's your rules for equations. On the right-hand side, you have the fraction 75 over 90. Now, that's obviously not in simple form, so you want to find the biggest value that goes into the top and bottom. I know that 15 goes into both 75 and 90. 75 divided by 15 is 5. 90 divided by 15 is 6, so my answer should be 5 6. If I go back and check on my calculator, 5 divided by 6 equals 0.83 repeating, where only the 3 is repeating. So anytime you're repeating only one of the digits, okay, you're going to use this method right here. So you have to actually set up the expression and the equation, multiply your decimal times 100 and times 10, subtract it, solve the equation for x, and simplify your fraction. If you're repeating the same digit and there's no other digits inside of your problem, you can just use the 9 rule. Okay, so if there's one number after the decimal, you put it over 19. 2 numbers after the decimal, you put it over 99, and so on.